The solar system is made up of our star called the Sun and everything that travels or orbits around it. This includes 8 planets and their moons, dwarf planets, asteroids, comets, and smaller bits of rock and dust. The solar system is one of many solar systems that exist in the universe. Asteroids are lumps of rock and metal left over from when the solar system first formed. Most can be found in the asteroid belt, which is located between the planets Mars and Jupiter. Comets. Comets are cosmic snowballs of rock, ice, and dust. When one passes near to the Sun, it heats up and forms a tail. Gas planets. The four outer planets, Jupiter, Saturn, Uranus, and Neptune, are the largest planets in the solar system. They are mostly made of gas, and spacecraft are unable to land on them. Rocky planets. Closest to the Sun are the four rocky planets Mercury, Venus, Earth, and Mars. They all began their existence in the same way, but over time became very different worlds. Supersized. The solar system is so big that if the Sun were the size of a basketball, the Earth would be the size of a sesame seed, and it would be located more than 25 meters away. The Kuiper Belt. This ring of icy rocks lies beyond the path that Neptune follows around the Sun. Dwarf planets. Dwarf planets such as Pluto also travel around the Sun. These worlds are smaller than the other planets. Scientists think there may be dozens of undiscovered dwarf planets hiding in the solar system. Scientists believe the solar system began to form around 4.6 billion years ago. The Milky Way. The solar system is located in the Milky Way, a huge spiral galaxy containing billions of stars. They are grouped in arms that spiral outwards. All of the stars are traveling around a point at the center. Scientists think there is a supermassive black hole located there that sucks in anything that gets too close to it. Galaxy age. The distance from the edge of the galaxy to the other is 1,20,000 light years. A light year is the distance light towards in a year. The night sky. On a clear, dark night, it is possible to see the Milky Way stretching across the sky as a bright, cloudy band. Although the Milky Way is a spiral galaxy, it doesn't look like it from Earth because we are inside it. Black hole. The pull of gravity from a black hole is so great that not even light can escape it. Supermassive black holes, like the one at the center of the Milky Way, also fire out jets of energy. You are here. Our solar system is located on the inside edge of this arm of the spiral galaxy. Side view. When seen from the side, the Milky Way is flat with a bulge in the center. It's a bit like two fried eggs laid back to back. The Sun. Located at the center of the solar system is the Sun. It is a star like the ones you see in the night sky, a burning ball of gas made of mostly hydrogen and helium. It provides us with the heat we need to survive. The Sun is so massive that its gravity, the force that pulls things together, keeps the planets in orbit around it. Solar flare. Huge eruptions from the surface of the Sun are called solar prominences. They form loops because of the Sun's invisible magnetic field. Our star. Energy is constantly being generated deep within the Sun. It can take up to 1 lakh years for energy to reach the surface, but then it only takes 8 minutes to reach the earth. Sunspot. Dark patches that appear on the surface of the sun are called sunspots. They are cooler areas that usually last for a few weeks. The sun is so ginormous that all of the planets of the solar system could fit inside it hundreds of times over. Auroras, as well as heat and light, the sun blasts out special particles called solar wind. When these get trapped by Earth's magnetic field near the poles, they can create spectacular light shows called auroras. Auroras also happen on other planets such as Saturn. Mercury. Mercury is the closest planet to the Sun and the least explored of the four inner rocky planets. Its surface is covered in grayish brown dust and looks similar to our Moon, with lots of craters where it has been hit by space rocks. Scientists think there is no possibility of life here. Extreme temperatures. Mercury is a world of extreme temperatures. By day it is scorching hot, but at night it is very cold. Smallest planet. Mercury is the smallest of the 8 planets in our solar system. It is only slightly bigger than the Earth's moon. What's inside? Mercury has a rocky surface, but inside is a very large metallic core, part of which is molten liquid. Planet gazing. People have been observing Mercury for a very long time, but nobody knows who discovered it. Sometimes it can be seen from Earth around sunset and sunrise. These craters on Mercury look just like Mickey Mouse. Visible at night, Mercury is not the only planet that can be seen with the naked eye. The others are Venus, Mars, Jupiter, and Saturn. Planets to spot. When when viewed from Earth, planets can be spotted because they don't twinkle like stars. Venus. Venus is the brightest of all the planets seen from Earth. Mars. Mars appears a pale red color in the night sky. Jupiter. Using a small telescope, you can see more of Jupiter's moons. Saturn. When a small telescope, you can see Saturn's rings. These craters on Mercury look just like Mickey Mouse. Volcanoes. Venus is covered in volcanoes. There is evidence that some may still be erupting. Barren surface. There are no rivers or lakes on the surface of Venus. The only rain it gets is acid rain that would burn through your skin. Toxic clouds. Venus is covered in clouds of sulfuric acid. The atmosphere is so thick it would crush you in seconds. Earth's evil Earth's evil twin. Earth and Venus are about the same size and are made up of similar rocky materials, but that's where the similarities end. Venus is a deadly world. It's boiling hot, covered in volcanoes, and cloaked in an atmosphere of deadly poisonous gases. Venus is the hottest planet in the solar system. Atmosphere. Earth's atmosphere protects it from dangerous space radiation and contains gases like oxygen that we need to breathe. Life. Earth is home to an amazing variety of planets and animals. Water. About 71% of Earth's surface is covered by water. It is vital ingredient for life. Temperature. With its distance from the sun, Earth is the perfect temperature for life, neither too hot or too cold. Life on Earth. Although there may be life elsewhere in our solar system, we haven't discovered it yet. The only place we know has life for sure is Earth. Our home planet is at just the right distance from our sun for liquid water to exist and has all the other key ingredients to make life possible. Raw materials. The raw materials needed for life are found all over Earth. For example, in soil, however, soil needs water and energy from the sun before life can appear. Recipe for life. In the mixing bowl are the key ingredients needed for life as we know it. You will need raw materials such as oxygen, nitrogen, and carbon, liquid water, energy. What are we made of? From the biggest whale in the ocean to a tiny mouse, all life on earth has one thing in common. It is all made from the same stuff. It may not look like a whale, but a mouse is made of the same raw materials. Water. Liquid water is essential for life. It allows crucial changes to take place between raw materials. Life on Earth began more than 3.5 billion years ago. Energy. Life on Earth would not be possible without a constant source of energy, such as the sun. Stardust. Nearly everything that makes up our bodies and everything else on Earth was created when trying stars exploded. These explosions sent raw materials like carbon and oxygen hurtling across space, and these raw materials are what we are made of. That means that they are made of stardust. The moon. The moon is our closest neighbor and the only place in the solar system other than Earth that humans have set foot on. The moon is desert like with plains, mountains, and valleys, and a black sky. It is covered with craters because there is no atmosphere to protect it from space rocks. Moon landings. 12 people have walked on the moon, the first being Neil Armstrong. People have driven cars on the moon, called lunar rovers, and even played golf. On 20 July 1969, the first astronaut landed on the moon. Moon exploration. People last visited the moon in 1972, but the footprints they left will last for millions of years because there is no wind to blow them away. This means future moon explorers will be able to see them. Earth rise. This is the view of Earth as seen from Apollo 8, which was the first manned mission to orbit the Sun. The photograph was taken on Christmas Eve 1968, solar eclipse. Sometimes, when the moon passes between the Earth and the Sun, the moon briefly blocks out light from the Sun, causing an eclipse to be seen on Earth. Mining the moon. In the future, there could be moon base where people could live. Some scientists are even interested in mining the moon for resources they could turn into rocket fuel. How the moon formed. Scientists think the moon was formed when the solar system was very young and an object about the size of Mars collided with the young Earth. They think the moon is debris from the collision, pulled together in Earth's orbit gravity. The space race. In the middle of the 20th century, the USA and the Soviet Union were struggling to be most powerful country in the world. Both countries wanted to be the first to send spacecraft and people into space, and so the space race began. The first man-made object to travel into space was the Soviet satellite Sputnik 1. It was launched on 4th October 1957. The month later, on 3 November 1957, the Soviet Union sent a dog into space. She was called Laika and became the first living creature to orbit the Earth. But the Soviet Union sent a human to space first. On 12th April 1961, Russian cosmonaut Yuri Gagarin orbited the Earth. In April 1959, the US introduced its first group of astronauts known as the Mercury 7. They were an elite group of pilots who did special training to travel to space. In September 1962, US President John Kennedy set the goal of landing a man on the moon by the end of the decade. We choose to go to the moon. In a further trip on 18 March 1965, the Soviet cosmonaut Alexei Leonov became the first person to walk in space, but the Soviets were still ahead, and in June 1963, Valentina Tereshkova became the first woman to travel to space. However, the United States were first to the moon. The Apollo 11 mission launches on 16 July 1969 and successfully landed on the moon 4 days later. That's one small step for man, one giant leap for mankind. On 20 July 1969, Neil Armstrong and Buzz Aldrin became the first people to walk on the moon. The space race was over. Living in space, the International Space Station ISS is the biggest object even flown in space. It orbits at around 400 kilometers above Earth, and a team of astronauts have lived and worked here since the year 2000. It is our first step towards exploring deeper into the solar system. Robonaut 2 is NASA US Space Agency robot astronaut that lives on the space station and helps the crew with simple tasks such as changing air filters. Its head has cameras which work like eyes, and its hands can operate simple tools. Experiments. Astronauts do lots of scientific experiments on the space station to help us understand more about the effects of living in space. This will be useful knowledge for future deep space exploration. Canadarm 2 is a robotic arm that moves equipment around the ISS. Science experiments are carried out in the Columbus Laboratory. Keeping fit. There is no gravity in space, so astronauts exercise every day. It keeps them healthy and stops their muscles from getting weak. The Soyuz capsule carries people and supplies to and from the ISS. Oxygen is generated in the Tranquility module. The Japanese Kibo laboratory has a mini airlock so astronauts can put experiments outside. From the space station, you can see entire countries' storms from above and 16 sunsets and sunrises every day. Spacewalk. Sometimes astronauts have to go outside on spacewalks to repair the ISS. They wear special suits to protect them from the harsh environment of space. Spacesuit. In outer space, there is no air to breathe, and the temperature can quickly change from being very hot to very cold. To survive, astronauts must wear spacesuits. They are like an astronaut's personal spacecraft, allowing them to do important jobs such as repairing the space station. Lots of layers. Spacesuits have 14 layers of material to help keep astronauts safe. Some of these layers protect them from dangerous objects that fly through space. Life support system. Worn like a backpack, the life support system contains oxygen for the astronaut to breathe and a battery for electrical power. Gloves. Spacesuit gloves have heaters in the fingertips to stop an astronaut's fingers from getting cold. Helmet. Astronauts see out of a clear plastic bubble and also have a visor to protect them from the sun's harmful rays. Display unit. Astronauts operate their life support system using controls on their display unit. Boots. Astronauts can attach their boots to special foot re- retrains on the space station to make working in space easier. Flying free. This space jetpack is called a manned ma- maneuvering unit. It was used by astronauts in the 1980s to travel in space without being tied to their spacecraft. Today, astronauts have smaller versions in case of emergencies. In 1971, astronaut Al Worden performed space work on his way back from the moon. What's it like to be an astronaut? Dr. Pierre Sellers is a British American NASA astronaut and climate scientist. In his space career, he made 3 space shuttle flights. He completed 6 spacewalks during which he helped to build the International Space Station. Space space is the new frontier. It is to us what the oceans were to sailors 1,000 years ago. We have to cross space to get to the planets in our solar system. One day we will travel to planets around other stars. I hope future space explorers will travel to Mars, then the moons of the outer planets. Zero gravity is great fun. You can float through the air down the big main corridor of the space station. It's like magic, but the view of the Earth is the main thing. From the ISS, you can see over 1000 miles in all directions. It's hard to sleep in space. When you close your eyes, you feel like you are falling, and so you wake up. You can't shower in zero gravity, the water would go everywhere. So you wipe yourself down with a wet washcloth, which works okay. The low works using an air suction fan to make everything go where it's supposed to go, and that works fine too. The best part of being an astronaut is spacewalking. Being outside the spacecraft, you have a beautiful all round view of the Earth and space. Spacewalking. Spacewalks can be very tiring. For this one, Pierce was outside for more than 7 hours. Professional astronauts. Before becoming astronauts, Sunita Williams trained as a pilot and John Higginbotham was an engineer. How do you become an astronaut? Currently, you have to be one of the following to be a professional astronaut: military test pilot, engineer, medical doctor, or scientist. So, study hard on the STEM subjects: science, technology, engineering, and mathematics at school. They are hard to begin with but fascinating and worthwhile. Mars. Mars is nicknamed the Red Planet because of its rusty soil. Like Earth, it has a rocky surface, polar ice caps, mountains, valleys, and clouds in the sky. However, the fourth planet from the Sun has a far more extreme environment than ours. It is very cold and dry with a thin, unbreakable atmosphere. Mars moons. Mars has 2 moons called Phobos and Deimos, which are much smaller than Earth's moon. Their names mean panic and fear. They were probably asteroids pulled towards Mars by its gravity. Olympus. Olympus Mons, towering high above the Martian landscape, is Olympus Mons. It is the largest volcano in our solar system and nearly 3 times as high as Mount Everest. Valles Marineris. Valles Marineris is a 4,000 kilometer crack across the surface of Mars at parts 7 kilometers deep. It is a system of canyons including the vast Coprats Chasma. Weather of Mars. Like Earth, Mars has seasons. This is because the planets are titled at similar angles. Different parts of the planet lean towards the sun at different times during the year, making it warmer or cooler. At an angle, Mars is titled just 1.5 inch more than Earth, so it has a similar range of seasons. Seasons on Mars last longer because it takes longer for Mars to travel around the Sun. Dust storms. On Mars, there are huge dust storms that last for weeks. So much dust is kicked up that they can be seen by telescopes on Earth. Whirlwind on Mars is known as a dust devil. Exploring Mars. Scientists have always longed to explore Mars. They believe that in the past the red planet could have been far warmer and wetter than it is now. There may once have even been life on Mars, and tiny life forms such as bacteria could live on the planet. Today, many spacecraft have already visited Mars, and in the future, humans will too. The Curiosity rover travels at just 3.8 cm per second. Water on Mars. In 2015, NASA found the strongest evidence yet that liquid water exists on Mars. This was a hugely exciting discovery because scientists looking for life in our solar system think that where there is liquid water, there could be life. These channels in the rock suggest water may have flowed here. Curiosity has 17 cameras on board. As well as taking photos, this camera can fire a laser to clean away dust from Martian rocks. Curiosity robotic arm holds tools for examining the surface. Curiosity rover. This photo of the Curiosity rover was taken on the surface of Mars. The six-wheeled, car-sized robot lives and works on the planet, operated by a team of scientists back on Earth. Their instructions take about 15 minutes to reach Mars. Wide, grippy wheels help the rover travel over bumpy terrain. Human exploration. One day people will walk on Mars. Astronauts will see the landscape with their own eyes and become the first humans to walk on another planet. Even if no life is found, reaching Mars will be a crucial step on the way to exploring the wider solar system.